Hey guys, what's up? So here's our 6.6 video. Sorry I'm getting it to you late. My grandma's been in and I've been taking care of my new pup, so I've been a little delayed, but I'll make sure to get the 6.7 one out to you guys by Monday. I'm going to extend this deadline to next Monday or to next Sunday as well, but I'm going to show you some examples, okay? So the first one, so our first example, so example 1, so we're going to try and solve with common bases, okay? So that's a really badass. Solve with common base. Okay, so here's our equation. Okay, we have 1/2 to the x plus 7 equals 4 to the 3x. Okay, so technically right now these aren't at the same base, but we can rewrite them in the same base. Okay, so 1/2, technically speaking, is 2 to the negative first, x plus 7, and this is 2 squared, 3x. Okay, so now we can write this as 2 to the negative x minus 7 equals 2 to the 6x, because basically what I'm doing is I'm taking this expression, putting it in there, taking this expression and putting it in there. Okay, so now we can get rid of our 2's, okay, because we'll do log base 2 and then log base 2. So our 2's will cancel there. So then we're left with negative x minus 7 equals 6x. We add an x, we add an x. Those cancel. So we have negative 7 equals x. Oops, sorry. Negative 7 equals 7x. So x equals negative 1. Okay. So that's how we would solve that one. All right. I'm going to show you another one. So let me make this letter A. Draw a line. This is B. So B is going to be 25 to the 3x equals 125 to the x plus 2. So we can get these in base 5, right? So this is 5 squared to the 3x equals 5 cubed, because 5 cubed is 125, to the x plus 2. Okay, then we distribute, because that's our power of a power property. So this is 5 to the 6x equals 5, and I'm going to take this and distribute. 5 to the 3x plus 6. Do log base 5, get rid of that. Log base 5, get rid of that. So I have 6x equals 3x plus 6. Subtract 3x, subtract 3x. 3x equals 6, and x equals 2. Okay, so that's how you do it when it's the same base. Okay, same base. All right. Now, here is our next example. Okay, so we're going to rewrite, so example 2. So rewrite exponential equations using logs. Okay, so we have 17 equals 4 to the x. Okay, so we need to figure out how to rewrite that. Okay, so what we have to do here, okay, what we have to do here is we have to write the equation using the powers of 10. Okay, so eventually we want to get we want to rewrite it using the powers of 10. Okay, so 17 equals 4 to the x. So this is going to be 10 to the log of 17 equals 10 to the log of 4 to the x. Okay, and then to get those out, to get the 10 or to get the log of 17 and the log of 4x out, we would do log of 10 and log of 10 to the exponents. Those logs cancel, so then it's log of 17 equals log of 4 to the x. Okay. Let me do another example. This is, whoops, that's not a straight line at all. So example 3. So solve exponential equations using logs. Solve exponential equations using logs. Okay, so the equation we are presented with is 3 to the x plus 1 equals 5 to the x. Okay, so what we have to do first is we need to take the log of each side. Move this over here. Okay, so when we take the log there, oops, this becomes x plus 1 times log of 3 equals x log of 5. Okay. Now, we take this log of 3 and distribute it. So this is x times log of 3 plus log of 3 equals x log of 5. Okay, so we need to get our x's on the same side, right? So I would subtract x log of 5. So this is x log of 3 plus log of 3 minus x log 5 equals 0. Okay, so since we have our x's on the other side, we need the log of 3, or since we have our x's on one side, we need our log of 3 moved to the other. So I subtract log 3, that cancels, so I have x log 3 minus x log 5 equals negative log of 3. And since we have a common term here, the x, okay, I can pull out an x, which is x log 3 minus log 5 equals negative log 3. Get x by itself, divide by log 3 minus log 5. Those cancel, divide by log 3 minus log 5. So x is approximately, when you punch that into your calculator, x is approximately 2.15. Okay. You can also graph it using Desmos. So if you go to Google and type in Desmos graphing calculator, search that in Google, it'll come up. It's also on Clever. You can use a graphing calculator to figure out what the solution is. Okay. One more. So that was, I believe that was example 3. Yep, this is example 4. So solving log equations. So solving log equations. Okay. So we have the equation, the natural log of x squared minus 16 equals the natural log of 6x. Okay. So in this situation, okay, So since we have the natural logs, we need to do e to the natural log, e to the natural log, so those cancel. So this becomes x squared minus 16 equals 6x, okay? Now, we have a higher ordered term, okay? So we need to move everything to the same side and set it equal to 0. So subtract 6x. So this becomes x squared minus 6x minus 16 equals 0. See what that factors to. So it factors to -8 and +2. So our solutions are x equals +8 or x equals -2. And now we got to check. Okay, there's one thing we have to check for each time, and it's extraneous solutions. Okay, make sure it's extraneous solutions. Okay, so let's check the first one. So it's the natural log of 8 squared minus 16 equals the natural log of 6 times 8. So this is the natural log of 48 equals the natural log of 48. Oops. That checks out, so 8's good. Natural log of -2 squared minus 16 equals, equals the natural log of -2 times 6. So natural log of, let's see here. The natural log of -12 equals the natural log of -12. But the trick for this one is natural logs are undefined for negative values. So even though this works out and is equal to each other, it's undefined. So -2 is not a real solution, okay? So x equals 8, real solution. X equals -2. Extraneous solution. Okay? So that is lesson 6.6, okay? Let me know if you guys have questions. I'm going to post the link on Edsby, so it'll be on YouTube so y'all can watch, okay? Thanks, guys. I will see you today for the Zoom meeting.